Okay, so I hope this program was clear to everyone. Pass by reference and pass by value. We have seen through an example of cube by value and cube by reference. So if you have to do a pass by reference for a variable, you need to pass the address of that variable, and in the function definition, you have to mention about the pointer. And please remember, whenever you have to read this pointer, read it from right to left. Okay, so this is called n pointer. Nptr is a pointer. So nptr is a pointer of integer type. Okay, this asterisk will represent pointer. So nptr is a pointer of integer type, or it is representing a integer value. Okay, so now any question till here? So now let's move to our next topic we have covered till here. Now let's see what happen when we do a call by value and a call by reference. So what happens actually with these variable? Okay, so I am referring to the same example, cube by value and cube by reference function. So let's see what will happen in the memory, right? So this is step one. So right now I am talking about cube by value. When we pass the arguments to any function by their value. So in this case, when we are in the main function, okay, whenever this particular line will get executed, there is this number variable which will get a space in the memory, and the value of that variable is set to 5. Okay, and at this point of time, if you see a call by value function, there int n is again a variable because the program is already compiled. Okay, so n get a space in the memory, but the value in n is not defined yet. Okay, because we are executing this line. This is step one. Now let's move to step two. When we call this function, so whenever this function will get called and number is passed, this line will get executed, right? The control will come here, and at this point in time, since we are passing 5, okay, the value of n becomes 5, right? So in the very beginning, when this line is getting executed, the value of the local n2 function cube by value is undefined, whereas this number variable, the value is 5. When we call the function by passing the parameter by value, at that point in time, this n, the value of this n becomes 5 because 5 is coming from the function call. Okay. Then when we operate on this n, okay, the total, this particular line will execute, and 125 is the value that will get returned. Here, please note that at this point in time, when this computation is performed, the value of number is 5 and the value of n is also 5. Once we execute this return function and the function is returned back to this location, what will happen? The value of entire this thing will become 125, which will get assigned to number. Okay, and at that point, when the control is returned, you can see now n again becomes undefined, right? Because we have returned from the function. Now there is nothing, no call stack of the function cube by value, and therefore any variable which is local to that function will have a value undefined. You cannot access that value. Okay, and in the next step, if you will see, the number will get updated since this assignment will took place. Okay, and the value of number will become 5, and the value of n is still remain undefined. So this is what happened when we do call by value. Any question in this? Okay, so initially when we are in the main function, number is value at stored at number is 5 and the value at n is undefined. During the execution, both are having a valid values because we are inside the scope of this function. Once we come out of the scope of this function, the value again will become undefined. Okay, and the updation is made at this local variable to main. Now let's see what happened when there is a cube by reference. Okay, so when there is a call by reference, what happened? Let's see. So again, we are having this variable number and the value is 5 because we are already executing this line. At this point, there is this n pointer whose value is defined. So in pass by reference, we will take a pointer variable and n pointer, and the value is undefined, means this particular thing is not pointing to anything. Okay, since the program is compiled, some location is given to the pointer, but the compiler don't know what value to keep here. Now when we execute the program and we come to this call, right, once this call will happen, our control will go inside the cube by reference function. At this point, this pointer will get activated, and since we are passing the address of a number variable, this will start pointing to number variable. Okay, this call has been established. The pointer, this memory address has been assigned to n pointer. Okay, now when we deal with this pointer, which is the value that we are actually modifying? Since this is a pointer value, we are actually modifying the value of the main call. We are actually modifying the value of the main call, right? So this is what actually happened when we are having our call by value and call by reference. So in case of call by value, the actual value will get changed once the function return. Whereas when we are having call by reference, during the execution of this particular function, the value will get changed because we have actually passed the address of the variable which is defined in the main. Right? Any question in this? Yes, no?
No, ma'am.
All right. So I hope with this, it is clear that what is called by value and what is called by reference, what is the difference, what is the scope of these variables, as well as when to use what. Okay. So now let's move forward and let's have a look at a new qualifier, that is constant. We have already seen this constant with arrays, with variables, and this particular qualifier will actually allow us to, it actually enable us that if we declare any variable with a constant keyword, then during the program execution, the value of that particular variable or identifier will not get changed. Okay, this is why we are using a constant keyword. Now let's see how we can use this with pointers, right? So now this constant qualifier enables you to inform the compiler that the value of a particular variable should not be modified. In general, this is doing this, right? So constant qualifier is used to enforce principle of least privilege. Now this is a very important concept of software engineering. Okay, principle of least privilege. So when you will learn this software engineering subject, you will learn that whenever we are developing any software, we have to maintain this principle. Now what do you mean by principle of least privilege? So let's see what actually it is. So principle of least privilege will actually, tell you that you are passing enough access to the data to any function, okay, so that it can perform the specific task which for which it is written, but absolutely no more. So what I mean by this is, whenever we are giving access of the data to any function, whenever we are passing the access of the data to any function, we have to make sure that only limited amount of access has been passed, or only the sufficient amount of access has been passed so that the function can accomplish its work in a proper manner without any difficulties, but it should not be anything more. We should not give access anymore. Okay, this is the principle of least privilege, and in today's class we will have a look at different privileges. Okay, then you can decide accordingly that when to use what, or when to use constant, when to use pointers, when not to use pointers, etc., etc. Okay, so this is just for a general knowledge. Previously this constant qualifier is not included in the C programming language, and there are many programs, they are called, legacy programs, that are already made in using the C code. Okay, so now people are modifying those old C codes and including this particular constant qualifier into it to achieve the principle of least privilege. Okay, so there are many projects, if you see, going on. So the aim of that project is just to convert the already available software into a modified software which will have significant opportunities of improvement, okay, using this constant qualifier. So it is very important that whenever you make any program, so whenever you go into some company and you start developing a software or a project, you have to keep in mind these principle of least privilege. And actually everything will work. Okay, it doesn't matter you put constant, you don't put constant, everything will work perfectly. But you should know when to use what, okay, to avoid the problems that can occur in future. So we will have a look at some of those problems as well, right? Okay, so now there are six possibilities in which cases we have to use or not use this constant qualifier. Two are with pass by value, and there are four possibilities with pass by reference. Okay, what are the two possibilities with constant pass by value? Either you use constant, or you make a constant variable, or you make a non-constant variable. Okay, so use constant or not to use constant. So this is a simple two cases which are happen, or which are possible with a normal variable, or whenever we are saying that pass by value parameter, whenever we are passing the value as a parameter. And there are four possibilities with pass by reference parameter passing. Okay, so we will have a look at all the six cases. Okay, so by default, you know that all the function calls that we have seen till now, whenever we pass a value, or whenever we pass an argument to the function call, it is by default passed by value. Okay, except array, everything is passed by value. Okay, we just pass, so whenever we call our square function, we just call square of this number. Okay, and by default this is passed by value. Now if the copy is modified in the function, the original value in the caller does not change. This is what pass by value means. We have already seen, whenever the value, there is some changes in the value inside a function, it will not affect the original value, because we are making a copy of that argument. There is a local copy of that argument inside this function. Okay, in many cases, a value passed to a function is modified so the function can accomplish its task. Okay, so in many cases, this is required. And this is a very simple case, right? So can you give me an example of this? When we pass a value in the function, and to complete the task, function need to modify that value. Any example of this?
रिकर्सिव फंक्शंस में शायद होता है।
Yes.
मैम रिकर्सिव फंक्शंस में ऐसा होता है।
Not exactly. Recursive function will not change the value of the variable. It is not compulsory that they will change the value of the function. they will call the same function with a little smaller version of problem. Okay, so if we are saying n is equal to 5 and we are calling the function with n minus 1, this will not change the value of n. The value of n still remain 5. Okay, so this is not true in all recursive call actually. See, whenever you are, suppose, a counter variable, and this counter variable is taken from the user, for example. Okay, so user will say, okay, counter variable is 10. Now you want that, you know, how many. So if the user will give us 10, then I want to print from 10 to 1. Okay, this is a simple program. When you pass this counter to a function, say printing function, okay, and I am passing this counter, maybe I am keeping this name. So what I will do, I will make a for loop, okay, and I will initialize this counter. So there is no need to initialize because it is already initialized with 10. Okay, if the value of counter is 10. So what I will do, I will just check that whether this is less than equal to 10, and I will keep on decrementing the value of counter variable. Now here, there is the requirement to change the value which is passed in the argument. Okay, we are actually changing the value of this local variable. Okay. So generally, in many cases, the value that is passed to the function, it needs to be modified in order to accomplish the task. Okay, but there are some cases where you should not alter the value which is given by the caller function. Okay, you have not, you don't have any rights. You don't want that the function will change the or manipulate the value of this, even if it is doing it in the copy version. Okay, we are not changing the original value. The function is changing its local copy, but still you don't want to do that. Okay, so let's see the example of that. So consider a function that will take a single subscripted array and its size as an argument, and then the job of that function is just to print all the elements of the array. Now in this case, okay, what you will do, you will loop through the array and output each element of that array individually, but you don't want the function to alter the size of the array. Are you getting my point? You don't want the function to alter the size of the array that is used inside the function body. Okay, why? Because it may cause some access to unauthorized memory. Okay, because you want that this size is given and it is fixed. There is no need to change the size of the array. It is given by the main function, right, or the caller function. Along with this, you also want that the print function will not change the content of the array. The function just print whatever value is written there. Okay, there is no need to change the content of the array. There is no need to change the size of the array. In such cases, what we can do is we can make use of constant qualifier. Okay, so if a variable does not or should not change in the body of a function to which it is passed, the variable should be declared as constant. Okay, and this will help us in accidental modification, whether they are intentional or whether they are unintentional. Okay, it will help us so that the function will not actually modify the original value and not even the copy of the value. Okay, and if the function will try to do so, the compiler will raise an error because this constant keyword will let compiler know that please don't allow any change to the value of this variable. Am I making sense here? Yes, no?
मैम एक क्वेश्चन था.
Yes.
मैम जो क्विज के अंदर क्वेश्चन आया था ना कि अरे को प्रिंट करवाने में अगर हमें उसकी वैल्यू चेंज नहीं करनी,
हाँ.
तो क्या यूज करेंगे? तो उसका आंसर भी यही था एक्चुअली उस टाइम पे.
Exactly. And we have covered this constant.
यस मैम, बट मैम उसका आंसर ये नहीं हो सकता क्या कि हमने ना अरे की कॉपी बना ली उस फंक्शन में?
सी, जो हमारा एरे है ना, वो बाय डिफॉल्ट पास बाय रेफरेंस कॉल होता है. अगर आपने कॉपी बना ली तो भी आप एरे की वैल्यू को चेंज कर सकते हो.
ओके मैम।
ठीक है, तो अगर आप एनफोर्स करना चाहते हो कि nobody, even accidental, nobody can change, no function can change the value of the array, then you must use the keyword constant, otherwise there is no other way actually.
ओके मैम, बट उस टाइम आइडिया नहीं था कांस्टेंट फंक्शन का।
Okay, this is not a function, first of all, this is a
मैम
keyword
ओके,
qualifier.
कीवर्ड का।
Yeah, and actually we have actually covered it. Maybe you have missed that part of the lecture. If you have seen the recording, we have covered this constant thing previously also. Okay, now we are repeating this because we want to see how we can use it with pointers.
ओके मैम, एक्चुअली आई वाज कंफ्यूज्ड दैट्स
Okay, okay, no problem. But it is always better to ask. Okay, so it is good that you have asked this question. So constant can be used with variables, simple variables. Okay, so that nobody will alter the value of this variable once it will get defined for the first time. It can be used with arrays, both one-dimensional arrays and multi-dimensional array, to make sure that nobody can change the value of elements of this array. And this constants can be used with the pointers as well. Okay, so we will just have a look at this thing as well. Okay, so please remember this. This is a very important thing to keep in mind, because you know many C programming, uh, many softwares which actually develop in C make a very good use of constant qualifier. Okay, so any question till now? All right. So okay, so this is a common error. Let's read what is written here. Being unaware that a function is expecting pointer as argument for pass by reference and passing argument by value, some compiler take the value assuming they are pointer and dereference the value. Okay, so this is a programming error, and this error you will get at runtime. So what does it mean? Suppose we have written a program, or let me take anything, let's say sum. Okay, sum is a function, and this sum is actually taking a pointer type variable. Okay, int pointer to something, right? And you are passing a simple element, you are passing number there. So what happened at the compile time? You will not get any error. So this is the calling, and this is the definition. Okay, so let me return void. Okay, so at the compilation time you will not get error, but what happened, this will get assigned to the pointer, and when pointer will try to access this memory location, you know, you will get error. So this is called runtime error. The error that you will get during the execution of the program are called runtime error, and this is generally a memory violation error, because you are trying to access a memory location which you are not allowed to do. Okay, so sometimes you get segmentation fault. This is a very common error which occur in C programs, and the reason of segmentation fault is you are trying to access a memory location which you are not allowed to do. Okay, so please keep in mind, whenever a pointer is declared, you have to pass the address. Whenever a normal variable is declared, you have to pass the value. In either of the cases, you will get the runtime error. Okay. All right. So now let's see how we can use the constant qualifier with pointers. I hope it is clear that how to do it with pass by value. If you want to make the things constant, variable constant, use constant keyword while passing the value. So what you have to do, you have to make the constant copy during the function call. Okay, so constant int array. So if you use make use of this keyword during the function call, this is a function call. Okay, then it will not allow inside the function. Whenever you try to change the value of that array, you know, there is a compilation error. Okay, now let's have a look how we can use it using pointers. Now, I have already told you that there are 4 ways in which, you know, pointers can be passed to a function. Now, what are those four ways? Please pay attention now. The very first way is non-constant pointer to a non-constant data. What does this mean? Non-constant pointer to a non-constant data. So what is a non-constant data? if I say int x equal to 5, this is a non-constant data, meaning after few, after when the program execute, I can change the value of x from 5 to 7. Okay, anywhere in the program, I can still change the value of x. So these are called non-constant variables or non-constant data. Okay, if I declare it in this way, constant int x equal to 5, and later on at some point in time, if I will write this line, okay, there is the error. I cannot change the value of x because it is defined as a constant type, right? So this is called non-constant data. Now, what do you mean by constant and non-constant pointers? So now let's say I declare int pointer y. Okay, so how to read it? Y is a pointer of integer type. Okay, so it can point to integer variable. Now, if I say y equal to n%x, it means, so in the memory, what will happen? This is y, this is x, y is pointing to x. Okay, something is stored in x. Let's say 5 is stored, and this is pointing to this memory location. Later on, what I will say that I have another variable, let's say z equal to 15, something like this in the memory. Somewhere here z is there. I can say y, after some time I can say y equal to n%z. Means now y is not pointing to x. Now it is pointing to z. Okay, and suppose 15 is stored here. This means this is called a non-constant pointer. Means during the execution of the program, I can change where the pointer is pointing to. Are you getting my point?
Yes, ma'am.
Okay.
Yes, ma'am.
If I say constant, okay, int something like that, we will see the right way actually how to write it. Now, what is this? What is this?
Constant pointer.
Yes, this is a constant pointer. Now, what do you mean by constant pointer? Constant pointer means, so once the, some address is allocated to the pointer, you cannot change that particular address, right? So if I execute this line, there is no error. Okay, x start pointing to y start pointing to x. Okay, this line will execute perfectly. But whenever we encounter this line, there is an error. Why? Because this is a constant pointer. You cannot change the location where it is pointing to during the program execution. Okay, so this is the difference between constant pointer, non-constant pointer, a constant variable or constant data, and a non-constant data, right? So since there are total 4 cases, so as per that there are 4 possibilities. So the pointer can be passed to a function in these 4 ways. So the first way is non-constant pointer to non-constant data, both are non-constant. Second possibility is constant pointer to non-constant data. Third possibility is non-constant pointer to constant data. And fourth possibility is constant pointer to constant data. Okay, and these 4 are having different level of privileges. Okay, so we will see in detail one by one, and I will also let you know when to use what. So from now on, whenever you do your programming assignment and whenever you write even the single program, please make sure these 4 points into mind and work accordingly. Write your program accordingly. This will really help you to be a very good developer actually, or efficient developer. Okay, it will also reduce the possibilities of errors. Okay, so any question till now? Okay.
Yes, ma'am.
Yes.
Ma'am,
Yes.
ma'am, can we use pointer y equals to x to assign the value in the y? Asterisk y equal to x.
Yes, yes, you can do that. S
मैम
Y. Yes, sorry.
मैम तो उसे हम पास बाय वैल्यू बोलेंगे पास बाय रेफरेंस बोलेंगे
So first of all, there is no function call. So there is
तो मैम
no.
अगर if we do it in a function call
So you have to tell me what you are asking again actually. So yes, now tell me what you are asking. Repeat your question.
ma'am if in the place where we do pass by reference and we call, in a function call we put a y
So
in
for
place of
example,
them.
I think what you are saying is something like this, right?
Yes,
Suppose I
ma'am.
have this, okay, and this is the function. This is a pointer, right? So what
Yes,
you want to do is when we do sum of pointer, what to write here?
ma'am. Here a number.
But number is a variable, simple variable.
Okay, ma'am.
Okay, so this is actually not allowed. Okay.
Okay, ma'am.
Yeah. So, okay, now let's start with our first example, which is when to use non-constant pointer to non-constant data. And this is actually the least level of privilege because we can change or the function can change everything. The function can even change the pointer. The function can also change the value of the variable where this pointer is pointing to. Okay, so please remember this highest level of data access is granted by non-constant pointer to non-constant data. We are giving highest level of data access. Nothing more can be given. Okay, you are giving all the rights to the function that you can change the the value of the pointer. You can even change the value of the data to which it is pointing. Okay, so this is the highest level of access. Now, in this case, the data can be modified through dereferencing the pointer. Okay, you can just go to say y and change the value, say 10. It will actually change the value of x where y is pointing. Okay, even you can modify the pointer and you can say that now y don't point to x, now you start pointing to z. So both are allowed. So this is called highest level of access. Okay, now a declaration of for a non-constant pointer to non-constant data does not include constant keyword because both are non-constant, so there is no need to define or include constant keyword. Such a pointer might be used to receive a string as an argument to the function that actually process on each character of the string, and it would like to change the character of the string as well. Okay, so suppose if we want to print a particular string, we have not seen string as of now, but assume it as a character array. Okay, an array, single dimensional array of character type. We will cover string a little later. After pointers, we will go on strings. Okay, so if a pointer want that if a function want that, okay, I would like to receive a string and I have to perform processing on that string and I have to make changes in possibly each character of the string. Okay, in this case, we want non-constant pointer and non-constant data because we have to change the data also and we want the pointer to point each time at some different location. Okay, so we want both things to be non-constant. Now let's see the example. So this is the example. Now let's read this first. So there is this function convert to uppercase. Okay, let me show you the function actually. Yes, this is the function convert to uppercase. Okay, this will actually take a character array pointer and it will convert all the strings letter which are there in the string to uppercases. Okay, so we declare it as non-constant pointer to non-constant data. Now the function process the array string one character at a time and we will make use of this particular class function to upper. Okay, to upper. I don't know whether it is double P or a single P. Yeah, it is actually a double P, right? Yeah. So to upper, this is a function which is defined in C type.h library, right? We will cover this library in detail in whenever we learn about strings. So, but please remember for now that C type.h is a standard library which will allow us to have multiple functions related to characters and strings. Okay, and to upper is a function which will convert the original letter into uppercase. Okay, so let's see how we can make this program. So we are having this string is the name of the character array. Okay, and these are the characters that are assigned to it. So we are printing before conversion what is the string, then we call our conversion function. Okay, and then we will print the string after calling the function. Now what will happen in this function, let's see. So convert to uppercase will actually so this is the s pointer. S pointer is a pointer which point to character type data. Okay, so this is pointing to actual string. String is an array. Okay, and something is written there, so we are pointing to this string. Now what we are saying is this: we have to execute a loop which will actually iterate through all the character, and you have to execute this loop until unless the value which is pointed by sptr will not equal to null. Okay, if you remember when we cover character array, I already told you that the size of this character array will be 1 plus the number of characters which are written here, right? And what is that 1 plus for? Yes, anybody remember?
Any combination.
Single character.
Yes, this is the termination character, right? So automatically this character will get added at the end of the character array, right? So whenever you define a character array, this will automatically get added to let us know that we are this is array will get complete, because space is also allowed here. Okay, so space is not a string terminator. You have to keep continue count the space also as in character, and whenever you come across this symbol, just stop. Okay, so when we define a character array, how it will get stored in the memory, this entire thing will get stored, and at the end this will get stored. Okay, this is called string terminator. So what we will do, so we will just run the loop till this. So this is actually point that the character array will complete it, and each character, what we will do, we will store the value, or we can say we can convert the value to uppercase and store it. Okay, and we are incrementing the pointer. So right now the pointer by default is pointing to string 0. We will perform operation on this character, and then we are actually modifying the pointer. We are saying, okay, now please point to second location. Okay, so 0 1 2 till whatever the number is. So it will convert this character also into uppercase. Then we are saying, okay, now please point to next location, convert this number also, then point to next location. So what we are doing, we are changing the value of the pointer also, even we are changing the value of the elements or the data also to which it is pointing. Okay, and therefore we need non-constant data and non-constant pointer. Am I making sense here? Yes. Yes, no.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So can you see the use of non-constant pointer and non-constant data? See, we can increase the value of pointer. Why we can do this operation? Any idea?
Non-constant actually.
Yes, it is non-constant, but how we are sure that if we increase the value that is stored on this, if we increase the value by 1, it will start pointing to next location.
Ma'am, because in an array the address are in a continuous, they are in a continuous address.
So array is allocated contiguous memory location, right? Array is allotted a contiguous memory location. So this is the first reason. Okay, so if something is stored at 000, the next character will stored at 0001. Okay, and this is also true. So one point is this, very right. The second point is character will take only 1 byte. Okay, therefore only we will incrementing only by 1. Right, if it is an integer, we have to increase it by 4, then only next element will get pointed. So maybe you can try this with integer array. Define int a some elements and just increase all the elements by say some constant number, and you make use of non-constant pointer and non-constant data there. Okay, in that case you will observe that if you will increase by 1, then it will not do anything. Actually you have to increase it by 4. Okay.
Yes, ma'am.
Yeah. So any other question? Okay, now let's see the second possibility, non-constant pointer to a constant data. Okay, now in this what we can do, the data is constant, so we can modify the pointer value. Right now it is pointing to some data. The function can allow the pointer to change the value where it is pointing, but you cannot change the data to which it is pointing. That data is always constant. Okay, so a non-constant pointer to constant data can be modified to point to any data item of appropriate type, but data to which it point cannot be modified. Okay, because the data is constant. So such a pointer might be used to receive an array argument to a function that will process on each element without modifying the data. Okay, so for example spt, let's say the example of sptr only, and we are having some string here, suppose. Okay, now in this what I want is this, I would like to change every time I would like to change the location where it is pointing to, I want to increase it, right? But I don't want any changes to occur in the elements of the this string array. Okay, in such cases I can use non-constant pointer with the constant data. Now let's see how to use it. Okay, so suppose I want to print the characters of this array. Now printing the characters, you don't want to change the value of that character, we just want to access the character. Okay, so how to declare our pointer? So we will write it in this way. Now see, this is very, very important. Please read this line. So we will write it like this: constant character pointer and sptr. So how to read it? Please read it from right to left. Sptr is a pointer, okay, to a character constant, right? Sptr is a pointer to character constant. It says that sptr is non-constant. It is a pointer, it is just a normal pointer which is pointing to character constant. So when you declare your pointer in this manner, it shows that we are making use of non-constant pointer to constant data. Okay, so the function uses a for statement to output each character of the string until it will come across the null character, and after each character is get printed, s pointer value is incremented, right? So this is a non-constant pointer. Now let's see the function. So this is the function. Again, this is a very similar function. The values are here. We will print the function before calling the function, and we will, no, actually what we are doing here, okay, so we are just calling it. Okay, so the string is this. no modification is required. So we are just calling our print character function and passing this string. Now see here, we will not use n%. Why we will not use n% here? Yes. Why we are not using n% when we are passing arrays?
It's an array. It automatically points to its address when called in this manner.
Yes, true. Okay. So whenever we write string, it is actually the address of the first location of the array. Okay, so no need to put n%. But can you see this declaration? S pointer is a pointer to character constant. Okay, and if you try to make any modification in the array, okay, then it will not allow you. So you cannot say sptr asterisk sptr is equal to, you know, something. Okay, you cannot say this. You cannot modify the value. There is one example for that as well. We will look. Okay, any question in this? Yes, no? Is it clear?
Yes, ma'am.
Okay. So what it will do, it will just print, okay, one character at a time. Okay, nothing else. Right. So, all right. Now, let's see our next example. In this example, this is a very simple example where we are actually, we wrote same thing, but we are actually trying to modify that data. Okay. Now, please look at this example very carefully. This is a very short program to explain you that what type of error you will get. Okay. So here what I did is just define one variable x. This is a non-constant value. Okay. This variable is non-constant because just int y is written. Then I am calling a function f and I am passing the address of this y. In the function f, I am mentioning it in this way. So I am saying x pointer is a pointer to integer constant. Okay. And it is actually pointing to y. Address of y is get passed. Okay. Now inside the function, if I try to modify the value of y, I will get the error, and this is the error. L value specifies constant object. Okay, this is the error you will get. Okay, so you cannot modify because we have used the constant keyword here. You can modify the x pointer value, but you cannot modify the data which it points to. Yes, are you following me? Any question? Yes, no?
No.
All right. Now, now arrays are aggregated data type. Okay. We are having a few more insight of this non-constant pointer to constant data. Let's have a look. What are arrays? Arrays are the aggregate data type that store related item of same type under one name. Okay. So if I write int a10, it says that this particular line, this particular array will store 10 items of integer type. Okay, related data item of same type. Now, later in this course, we will discuss a data structure called structures, which is also known as record. Okay, this will allow you, or these structures are capable of storing related data items of different types under one name. Okay, so whenever we define a structure, you can say that a structure is having 10 elements. One is of integer type, one is of character type, 5 is of float type, something like that. Okay, so structure allow us to store elements of different data types under one name. Okay, this is the difference between array and structure. We have covered arrays After few time we will cover structures also, right? We will, it is in the syllabus, so we will look at that point also. But what actually I would like to mention here is this: when a function is called an array as an argument, it is by default passed by reference. Okay, but whenever we pass structure, it is passed by value. It is passed by value. Okay, so entire copy of that structure is passed, and structure is very huge data type. Okay, it may have hundreds of element inside it. It may have like 5 arrays of size 100 of different types. Okay, so it is a huge data type. But whenever you pass this structure into the function, it is by default passed by value. What is the disadvantage of pass by value? What is the disadvantage?
एक्चुअल वैल्यू में चेंज नहीं आता
I am
जो उसकी
talking
सोर्स
about
होती है.
this is sort of advantage, right? You cannot have accidental modification. So this is the advantage of pass by value. But what is the disadvantage? The major disadvantage is the entire copy is made. So lots and lots of memory consumption is there. ठीक है, तो अगर 500 data items है, then there are 2 copies of this 500 data items, and if it is called in 5 different functions, then you can think of the memory consumption it will take. In each function, it will make a new separate copy of the entire data structure. Okay, so actually pass by value, if we talk about a simple variable, then it's okay, no big deal. But if you do a pass by value for such a large or huge data items, then this require execution time overhead of making the copy of each data item in the structure. Okay, and you have to maintain it for different function calls. So for each function call, there is a different copy, right? So what you can do is this: when structured data must be passed to a function, we can make use of pointers to constant data to get the performance of pass by reference as well as pass by value. Okay, so see, the advantage of pass by value is the original item will not get changed. The value of original item will not get changed. What is the advantage of pass by reference? Memory consumption is low because we are not making extra copies of anything. You are directly make changes in the original version. If you want to take advantage of both the sides, what you can do is this: we can use pointers to constant data. Okay, so this will allow you not to change the value of original data. And since you are using pointers, okay, so pointers allow you to do a pass by reference, so a different copy will not get made. Are you getting my point?
Yes, ma'am.
Okay, so this type of possibility is very important in such cases when you want to make use of both the world, or when you want to take advantage of both the world, pass by reference as well as pass by value. Okay, and I already told you what is the advantage. Pass by value, the advantage is accidental modification will not be there. So we are making it possible by using this constant data item. Okay, and the advantage of pass by reference is there is no need to make another copy, so we are using pointers to take advantage of that. So in that sense, non-constant pointers to constant data is an important concept. Okay, and when the pointer to structure is passed, only a copy of the address at which the structure is stored is available to the function, but the function is not allowed to change any of the original value because you can make it so that it is pointing to a constant data item. And to do so, what you have to do, you have to mention the constant keyword first, then the data type, then the pointer, and then name of the pointer. Okay, any question? So there is this performance tip: pass large objects such as structures using pointers to constant data. So when to use pointers to constant data? When you are having a very large object like structures, okay, and you want the performance benefit of both pass by reference and the security which is provided by pass by value. So performance benefit is provided by pass by reference and security is provided by pass by value. Yes, I am open for questions now.
मैम पास बाय वैल्यू को इम्यूटेबिलिटी की तरह बोल सकते हैं क्या?
Yes, you can say that you cannot change the value which is stored there. Okay. So to summarize, if memory is low, okay, if your memory is low and execution efficiency is a concern, then use pointers. Okay, because it will not make another copy, it will directly do changes in the original version. If you have enough memory, okay, and efficiency is not an issue because making a copy will take time. Okay, so two important concern is space and time. In computer science, these are the two major important concerns. Okay, all the algorithms will design to make both of this as efficient as possible. But it is observed that if there are more space, if any algorithm will take more space, then time will become less. And if it is taking more time, then space advantage you will get. Okay, so depending upon your requirement, if you are having low in the memory, you want a program to consume less memory, okay, then go for pointers. If memory is not an issue and efficiency is an issue, okay, so you can go for pass by value. Okay, actually always try to do it pass by value as much as possible because it actually enforces the principle of least privilege. Okay, in pointers you are actually giving the access to change the original copy. So from security point of view, pass by value is good, but from performance point of view, pointers are good.